All right, we just looked at how many pixels we can control with the Arduino. Let's take a look at power consumption, okay? So, powering up these pixels right now, we just have two lights on and they're not even full brightness, okay? So, it's not taking up much power and we're just running off the USB cord. So, we're doing all right there, okay? Whoops. Try to fix that. There we go. Okay, pull that out of the way. Okay, so what I'm going to do right now is set this to 255. Okay, let's start cranking this up, getting a little juice out. All right, I'm going to upload that, and it's going to be a little bit brighter here. You probably won't see it much in the camera. It'll probably just look like whiter. Oh yeah, you didn't see it much in the camera, but they're definitely brighter. Okay, so each of these individual NeoPixels here, we'll go back to the bench. Okay, I'm actually gonna turn these off and hit upload. Okay, so each of these pixels have a red LED, a green LED, and a blue LED. Okay, so the red LED can consume 20 milliamps. The blue LED consume 20 milliamps, and the green LED can consume 20 milliamps. Oh, oops, not talking to that one. Huh? Whatever. Just gonna hit reset. I still probably won't do it. I'll unplug and replug. Oh, there it goes. Cool. Okay. Just had that data not connected all the way. So red, green, blue, 20 milliamps, 20 milliamps, 20 milliamps. Okay. Okay. Keep that in mind here. Go back to this. Okay. So if I want to make one of these NeoPixels bright white, strip dot. Oh, in this case, it'd be strip 0 dot set pixel color 0 comma 255 comma 255 comma 255. Okay, and then I do a strip dot show. Okay, if I were to do this, what I would get is a really bright LED that's taking 60 milliamps of power because it's taking 20 for red, 20 for green, 20 for blue. Right? Oh, my bad. Because it's part of an array now. There we go. Okay, so 60 milliamps of power, right? So let's take a look at this strip here. This strip of 8 pixels. Oh, there it goes. Man, you can see through my finger with this. Super bright. Okay, let's bring our calculator back out. Let's clear this out. Okay, so 60 milliamps, and we've got 8 pixels times 8. Okay, 480 milliamps. Okay, that's about half an amp. So, not too much, right? It's a lot of light for a little bit of power. Clear this. Now, USB 2.0 can take 2000 or can provide 2000 milliamps of power. Okay, so let's say I've got it plugged into USB. That gives me 2000 milliamps of power. I want to see how many LEDs I can control. So I divide that by 60. That's LEDs at max brightness, right? Equals 33. Okay, I can control 33 pixels and make them all white off my USB 2.0 plugins. Okay, now it doesn't account for like the power consumption of the Arduino or any other devices you have hooked up to it, or like even that pixel right there that takes up 10 milliamps while it's on. That LED takes 10 milliamps, and so we're already taking up 20 milliamps right there, which I guess it does have that little bit of extra here, but it still doesn't take it into factor other things we have powered on. Okay. Okay, so let's say I don't ever want white. I just want like colors, right? I want to do my strip dot color HSV random 65536 m parentheses and parentheses, and there's already n parentheses. Okay, so I'm just gonna have it set random color to one of these things and do a strip dot show. Okay. Oh, whoops! I already did that. I need a delay. Delay of 500 or so. Okay, so these full colors. So if it was blue, it would look like. Let's see. Oh, that's right. Because we're arrays, strip 0. That color HSV. So strip dot set pixel color. Oh, it's definitely not going to compile now with this baloney here. Oh, whoops. Okay, get rid of that. Get rid of that. Okay, got to be patient. Hit upload. Enter, enter, slash, slash. That's what I should have done. Okay, so strip dot set pixel color. Oh, there it goes. Okay, so now it's changing to a random full color every half second. Okay, so keep that in mind, a random full color. So let's say I had a blue, right? 0, comma, so 0 red, comma 0 green, comma 255 blue. That'd be 20 milliamps, right? And so when it does things like purple, it doesn't do it like this, okay? It doesn't do 255, comma 0, comma 255. It doesn't do that with purple, okay? Because then your purples, your teal, your orangish would be super bright, and then your solid colors, your red, green, blue, would be like half as bright, right? So what it actually does is it runs them half as bright. So 127 and 127 making half red, half bright blue, which makes purple, but it still takes up 20 milliamps of power, right? So let's say I just wanted to set a bunch of LEDs to random colors here. So I'm going to pull out my calculator again. And I'm going to go 2000 milliamps off just the USB port, right? Divided by 20. This is a little bit easier math to do. So I can now control 100 NeoPixels just in random colors here. So depending on my program, I can run different amounts of NeoPixels, right? Let's say I just wanted one to sparkle, right? So instead of having like them all be different colors, I just want one to change. And so every single time it turns on, so I'm going to do int pixels equals random. Let's see, we don't have LED count anymore because we defined everything. So just 8. Okay. So set pixel color to, let's see, or yeah, the pixel number will be pixels. Okay. And then we'll do a show. And then what we're going to do here is just turn it off in memory. Color pixels, comma 0, comma 0, comma 0. Okay. So what we do is we turn it a color, we broadcast that on the data pin, and then we turn it off. But we don't broadcast that. We don't need to broadcast it yet, right? We don't need to broadcast it until we pick the next color, right? So it's already showed that one color, turn it off in memory, wait half a second, pick the new color or the new pixel with the color, and then show that. Okay? So instead of showing it twice, which is silly, We just let it show because in memory it turned the last one off. Okay, I'm going to upload that. Okay, so now our program, instead of having them all different colors, we just have one color at a time, right? So now the entire strip. Let's do this right. There we go. Okay. I gotta act like I've done this before. Okay. So now I could have like 2,000 pixels, right? If I had maybe an app Mega, like the Mega Uno. What is that? The Arduino Mega. Yeah, the Arduino Mega can support way more pixels. What was that? 20 something hundred? I forget what I saw. Maybe it was 16,000, 1600. I forget. But power wise, this runs 20 milliamps every color, and it just flashes a random one here. And just for fun, because this looks neat, I'm going to bring the delay down to 50, and it should go a lot faster. But power consumption, right? So if you're gonna run it not on your like off the Arduino power, but you're gonna run it on a power supply power, right? Like you have a big old brick, or you have one of the wall wart plugins that provides power. You need to give it power and ground to that wall wart, okay? To the Arduino, you need ground and data. So keep that in mind. That's going to come up later. Power and ground to the power supply, ground and data to the Arduino. So the Arduino won't be providing power, but the data needs to compare to something. The data will compare to ground, and then it'll actually send data through. Okay. So this is power here. And this is one of the easier videos. Thanks for watching.